Okay, let's begin our lecture on numerical analysis. We have only 2 weeks remaining, so hope to finish up our coursework with this is lecture number 11 for. So in the last lecture I have started the chapter number 4, and I have explained you something about the Taylor series. So the chapter number 4 is for the numerical method of solving differential equations, where we can study about the Euler's method, as well as Taylor method, Runge-Kutta method, as well as some multi-step method as well. So in this, I have sent you the notes, so you can refer those things. So I can do some exercises here. So numerical method for solving differential equation, single step method as a first title, where we have analyzed about the Taylor series method in our last lecture. So which says if you have the first order differential equation dy over dx of f of x comma y, then also we are having some initial condition. So we know with the differential equation, if you have the initial point, we can analyze the solution, the next solutions. Since we are considering a single step method, so we are going from 1 up to 1. For example, so we are so simply in the initial condition itself, we have y naught. So from that, using the definition, we can find the next step, which is y1, y2, step like that. We are going one step away, okay, with the single steps. So we also have discussed about what is about the Taylor series method, which has been defined from the Taylor series expansions. So we are, okay, give me a second. Okay, now for y of x1, so which is the next point of x naught, okay, we can say x1 which is equal to x naught plus h. So the h is a difference between the so likewise I said you, if this is our x coordinate and this is y coordinate of function of x, let's say, okay. So if you are having this is our x naught, okay, so this is x1, so we are dividing the interval into some points, okay. The next point we are taking the distance between these will be h, okay. So this we called as a step size, or the difference between the points x, okay. Now, this x1 can be written as, in terms of x naught, we have x naught plus 1 time h. So similarly, if you wanted to analyze about x2, you can say like x1 plus h, or if you use the x naught for this one, it will be x naught plus h plus h. It will be x naught plus 2h. We have analyzed everything like that earlier. So if you wanted to, xn can be, if you are taking from x naught, so it will be n times of h. So h we are fixing as a constant, okay. It's not different, it's a same one. So using the Taylor series expansion, this is our Taylor series expansion, which I have explained you. This is our error term, because we are just approximating until to the h to the power k, okay. Then the rest of the term we are taking as the error, okay. So as always, I also told you this Taylor series has been found for the particular point, okay. And also this error point also between the whatever we are finding. So since we are finding y1, so we can write this one also y1, okay. So the y1 is between, we are taking the point between this x naught and x1, therefore it is also belongs to x naught and x1. Sorry about that. So this has I have explained you clearly in our last lecture. So I can go a little further. So we have no, we just substitute a dy over dx f of x comma y. Give me a second. Okay. So from that we can find this is also we are taking dy over dx we can take as a f dash. Isn't it? So this is also dy over dx. Okay. So from this we can find the f double dash, f triple dash. Like that we can continuously we can compute the differential equation. I mean differentiation. Then when we are substituting in our equation number 2, which is the Taylor series, we are wherever I mean in this equation you can see equation number 2 says which is so y of x naught plus h times y dash of x naught. So if I substitute this one as my y naught, okay, then again I can write this one as well y1 of dash. Okay, so what we are doing is we are substituting our value. When we are doing example you can find out. So rather than y of x naught, I can write y of 1. Okay. Similarly, which we can write as a, y of x1, I can write as a y1. So y of x naught, I can write as a y naught. Okay. Plus h time y naught dash, which is scaled by 2 factorial y naught double dash up to this one. Okay. In this equation, we are, omitting the error term for something. Okay. For the approximation, we just avoiding the error term and we are getting this one. Also, I have explained you what is the meaning of single step method or one step method, which is if you wanted to find the y are to be computed by using the x2, x3 up to xn, the continuation of x1. So each steps we are proceeding. So which we called as a single step or one step method. Now we also have written this one also, no? So yi plus 1, which is equal to yi plus h of tk minus 1, which this is what I have explained to you at last, which is so like that yi plus h times. For the tk, we can substitute what is yi, I mean, yeah, plus y dash and y dash double dash, something like that. Okay. So what is, I'm just taking h away. So therefore one h is less in this series. Okay. That's what happens. So without the one h, we are taking this as a tk minus 1 of xi yi. So what is tk minus 1 xi yi? Wherever yi, I put fi. Okay. So this is something I think you can understand. So this kind of equation we called as a Taylor series method of order k. So what that says is, so our y1 should be, let's say, y naught plus h of y naught dash plus h squared of 2 factorial. So if I wanted to write in a full form, this is actually our, this will be y naught double dash. This will be 3 factorial of y naught triple dash. It goes up to where let's say k factorial over of y to the power of k differential equation of y naught. Okay. So since we are going up to the order k. So this is what this Taylor series method of order k. Okay. So you can see I have sent you the homework quiz as well on this. Okay. It is say for example, let's say they ask you third order Taylor series. Okay. So what you do is this is first one. This is second, this is third, this is fourth, up to this the kth one, isn't it? So if they ask you to stop until third, you have to stop here. Okay, you are approximating this much and you are omitting everything. Okay, let's say if they ask you up to fourth, so you have to go up to here. Okay, so this is how we're gonna do our example. Okay, so hope you understood that thing. Okay, so let me go further. So there is one note which is talking about our errors. Okay, so as I said you, the term, the remaining term we are taking as the error term. Okay, which also can be written as okay, y of epsilon I. It means yk plus 1, I mean differential of k plus 1 differentiation of, we are taking the epsilon I, which is between the point what we are looking for, 1 steps, okay? So the y of epsilon I. For the yk plus 1, you can also substitute f of k, because we have taken dy over dx as a f of xi y. Okay? So which kind, this is we called as a truncational error. It means we are truncating our equation. It means Taylor series, okay, for example, yi, which goes up to yi minus 1, yi minus 1 or dash. It goes up to, it's not ending, it goes up to infinity, let's say, okay, infinity terms. So we can't find infinity term now. So we are cutting for somewhere. Let's say y to the hk, kth order, okay? K factorial I minus 1 of k. And the next term we are taking as an error, okay? We are taking until this term, okay, this term up to kth order. And then there is the remaining full up to the infinity term we are taking as an error term. So when we going, so for example, x squared, when I differentiate, this will be, let's say 2x, again 2. What about the other, next one? Everything 0, 0, 0, 0, no. So there is something reducing it, if you go to the next higher stage, it will be reduced somewhat. So we can take it as a small amount of error, okay, which called as a truncation error. So truncation means we are truncating, we are cutting here, okay, cutting errors. So also we also called as a local error at the ith step. So whatever the step you are looking for, so that in that case we are having a local error. Okay. So what this is we know epsilon between the xi and the next point xi plus 1. But this is about the local error. So you may heard, I wonder, I don't know, you may heard or not. There's a two kind of error we can say. Local error, which is happening between what we are looking for. Okay, so for example, ith term, if I am taking ith term 1, this is my I plus 1, this is my I. So in between happening the error, we are called as a local error. But what if the entire equation's error? Okay, so if you see the full, this is our actually exact equation. I mean, exact solution will be, this is we are taking as our, so if you analytically solved our equation, I told you for the, I mean, algebraic or any kind of equation, we can solve this by two methods. One is we called as an analytical method. Okay, this is numerical method. So I think in your ODE sections, you are learning how to solve it analytically. Okay, in here we are solving numerically. Numerically in the sense, analytical in the sense, it's like a continue here to here, continuously you are finding the solutions. Numerical in the sense, you are discretely you are finding next point, next point, next point, next value, like that. Okay, so numerically we are finding step by step. So if they ask you to the entire error, global error, so this is our actually the exact solution or analytical solution. This is, let's say, this is our approximate solution. Okay, so actually, let's say, for example, you have something, let's say dy over dx equal to x over y, something like that. This equation you are solving in the ODE. Okay, ODE, you can use any separation method or any kind of method you are studying. You can solve now. After solving, you will find what is y of x. Y of x is equal to, let's say, for example, I'm not solving this one. Just say x square minus y or x plus 1. Something, this is your answer in there. Okay. But here I'm finding this is my answer. Okay, there with the error, I have this is my answer. For let's say for the third order, I get something like that. Okay. So what if they ask you the error solution? Okay, the point of I mean, this is your exact solution. This is my solution, what I got in the numerical way. So between that coming the error is a global error. It means the entire error of the I mean the problem. Okay. Hope you understood that thing. Okay. So we have finished about our Taylor series. So let's do one question so you may understand more than that. Okay. So you can go through our homework quizzes. So I hope I have sent you. Okay. So I'll do one question on it. Thus, as like our all the chapters, numerical work, it is little bit of time consuming as well as it is little bit of tricky, and also you have to memorize all the formulas and things. So it's, you have to be prepared for that. Okay. Also, as I said you in earlier also, if you wanted to do these stuffs using, you can use the calculator even in the examination. You can bring your own calculator and thing I have already told you. Okay. So only thing is you have to learn how fast you can solve this. The memorizing part, I mean, you can memorize the equation somehow. You can learn to memorize it. But the thing is, you have to execute it in here. Even though the same question what we are doing in the classroom comes in the examination also. So you can't, memorize and write like what you have done so far in other courses. So here you have to do some steps and you have to use your calculator and things, no? So only thing is your work, your part is you have to learn in between when you are studying this subject on your own. Okay, learn how you can use your calculator very efficiently for this very getting easy. I mean quickly. Okay, how I can feed the things calculator correctly and get the equation quickly rather than typing again. Okay, I told you you can learn those things. Uh, we can't teach you anyway, but it's better you to learn yourself. There are so many videos and things are there. You take some time and learn it. Okay, so that is your side. So the question may come according to the time limit, but if you wanted to use the time efficiently, you have to learn how you can, I mean, efficiently use the things and the calculator quick as possible. Okay, so that's your part. So let's begin one of the question. Okay, in our quiz. Let me do the first question. So you can do the rest, I guess. Okay. Okay, first one. The question is using the third order. As I said, we have studied for general case of kth order. So here, for the time consuming, they will cut out. They will ask third order, fourth order, but you have to know whichever the order, you have to know the entire equation. So using the third order Taylor series, so Taylor series method, so sometimes they may indicate which method you have to use for this question. Okay. Compute the values of the y as a solution of the following differential equation. Okay, they're asking the y. Okay, our equation is dy over dx, which is equal to x square plus y square, which is our function of x comma y. Also, we are dealing here with the initial value problems. They have given you the initial problem y of 2 is equal to 3, and they are asking you to find the values of y. Okay, at yeah. Okay, so this is how you have to understand the question first of all. Okay, so then you can proceed. Okay, now first of all, let's understand the question. Take some time to understand it. So they are asking third order. So I also, in my period, I use my even this is my examination script. I used to write the things what I'm reading like this. So I'll get some summary of my question. Then I can I can follow my answer. Okay. So you better learn those things also. So I have summarized my sentences in this simpler way. It should be third order Taylor series method, and they ask you to find the y at the point 2.1, 2.2, and dy over dx, this one, and this is that. And also, and here they have mentioned, okay, give me a second, I'll change the color. So in this, they have explained the, initial condition as well. So this is our y naught. Y naught is equal to 3. This is actually our x naught. X naught is equal to 2. Okay. Also, they have told you h is equal to 0.1. See, this much of details are in that question. So carefully you analyze first of all, then we can, start to compute. Okay, now, so see here, they say the initial point will be 2. Let's draw something, okay? So this is our x. This is my initial point, x naught is equal to 2, okay? And then the y will be 3, okay? And that is okay. So they are asking, the h will be 0.1, okay? This will be, h is equal to 0.1. So this is the kind of a single step, no? So x1 will be, what should be that? 2.1. Similarly, if you go for x2, 2.1 plus 0.1 will be 2.2. So what do you think? The question asking for the value of y of 2.1 is what? They have given you this one, okay? Y of 2, they have given us 3, okay? So they are asking y of 2 point is what? Y of 2.2 is what? So this is the question, okay? Now, so let's use our Taylor series techniques to, further. So now only this is the analyzation of the question. Now only we're gonna do our solution. Okay. So the solutions can be begin. Okay. Consider. Okay, you can write with me, and yeah, you can also help me to get the answers. Okay. Consider the third order Taylor series is. So in the general solution, we can stop until the third order. Okay. So for example, yi plus 1. You can either, in some book, they use yn plus 1. Okay. So you can try anything. So yi plus 1 is equal to yi plus h of yi dash plus h squared by 2 factorial of f of, yeah, I think I made a mistake earlier. Okay, give me a second. This is yi again. H cube over 2 3 factorial yi third order. Okay. So they are going up to 1, 2, 3, 4. Okay. Since they are taking kth order, in our kth order, we are going from yi to yi plus up to h to the power k, no. So you should know there are k plus 1 term. Okay. So here, if it is k term, it end at the k. So earlier, I think I have told you one less. Okay. So you have to be careful. So third term will be, you have to stop until h to the power 3 terms. Okay. So that's how the third term. So you can change the things. Okay. Now, so this is our equation number 1, which is the third order Taylor series. Okay. Which we're going to use it. So first of all, now let's use our, f of xy is, we have given, what is the f of x squared plus y squared. Okay. So what if you transform, okay. So this also can be written as this one. I think yi plus h of f of xi comma yi. Okay. So y dash is f of x comma y, isn't it? Am I right? Because when I explain you, I told you, so dy over dx is we called as a y dash, no? So that is f of x comma y. Okay. So you have to use that here. Okay. Plus h square by 2 factorial f dash of xi yi. Okay. So this one I can write x3 3 factorial into f double dash xi yi. Okay. So I think I need to go for double differentiate. I mean second differentiation. Okay. So what if I transform my xi as x as xi, y as yi? So everything will be changed, no? According to that, xi squared plus yi squared. Okay. Okay. Now let's have some time to analyze this differentiation of this function. Okay. So what about f dash xi yi? Can you try your answers? Similarly, f dash of xi yi. What you have to do, you just differentiate this one with respect to x. And also you have to know y is a function of x. So there you have to be carefully differentiate. Okay. So as this is our first question, I'll do that anyway. So this is our xi square by y square. So what about our f dash xi? It should be 2. Yeah, let's take no problem. 2xi plus 2yi times dy over dx, no? dy. So this is also yeah. So okay, give me a second. So rather than it is okay. Let's when we are differentiate, just keep as x comma y. Okay, then we can substitute. So let's say from this, okay, if you differentiate with respect to x, this one will have f dash of x comma y, which is equal to 2x plus 2y dy over dx, isn't it? Okay, so I'm going to continue in the next window. Please take down all the things. Okay, so let's continue there. So it means f dash of x comma y, we get 2x plus 2y dy over dx. So what actually, so earlier one is f x comma y, which is equal to x square plus y square. That is our dy over dx, isn't it? So wherever the dy or dx comes, we can substitute our this equation, okay, original equation, x square plus y square. So what do you think? This one, can you simplify this one? 2x plus 2x squared y plus 2y cube, isn't it? Is that correct? Okay. So let me continue first of all, then we can substitute things. So what about fx comma y? Hope you understood. Just please take the differential equation of this equation with respect to x. So you will get, for this one, if I differentiate with respect to x, I'll get 2. Again, it's like a UV form. So first of all, I'm going to take 4xy, okay, plus, please do yourself and check my answer. Okay, then 2x squared dy over dx. Okay, again 6y squared dy over dx. Okay, this is kind of a 2 plus 4xy. I can take the dy dx outside. Okay, 6y squared times dy over dx. Okay, now also I can substitute my dy over dx. Okay, so 2 plus 4xy plus 2x squared plus 6y squared times x squared plus y squared. So can you finalize this one? Simplify this. You can, multiply this with this. See whether the final answer will be 2 plus 4xy plus 2 to the power x4 and 8 x squared y squared plus 6 of y4. Can you try? Can you check these answers correct? Okay, so now I can f dash of x naught comma y naught, I can just substitute this, whatever the x, I can substitute as x naught, okay, plus 2 x naught squared y naught plus 2 y naught cube, okay. Similarly, yeah, give me a second. This one also I can substitute x naught comma y naught, okay. Yeah, this one just substitute 2 plus 4x naught y naught plus 2 of x naught to the power 4 plus x 8x naught squared y naught squared plus 6 of y naught to the power 4. We just substituting because that's what we're going to use in our equation number 1. Okay. Now, so just now we have started. We are not yet. Okay, this is our actually equation. Okay. So let me write first of all. Actually, my y I plus 1 I can write as, if you substitute these values, h time of what about my fxy? Yes, xi square plus yi square. Okay, plus h squared by 2 times 2xi. Check whether my answers are correct. 2yi cube. Okay, this is my second term, third term. After that, it's cubed by 6. I'm just 2 factorial will be 2, 3 factorial will be 6. Okay, that's what happening. Then plus 2 plus 4 xi yi plus 2 xi to the power 4. Just substitute whatever you got. X squared yi squared 6yi4. Okay, now this is our actual equation what we're gonna work out. Okay, so this much we have derived. So each questions, okay, this fi will be different. So according to that, this equation may be different. Okay, so this is your task. This can be get some half of your marks. Okay, then the next are just substitutions. It's not that hard. Okay, so now let's begin. So since they are asking the question to find out the 2.1 as well as y of 2.2, no. So actually what is 2.1? It's like a x1, which means x naught plus h. 2 plus 0.1, that's what it happens. Okay. Similarly, x2 will be x1 plus h. That means, sorry, 2.1. 2.1 plus 0.1. This will give you 2.2. So your task is to find y of 2.1 and y of 2.2. Okay. So which can be used, I think you also, we have done in our elementary differential equation, Pickett iteration. There we have what I is equal to 0, I is equal to 1, kind of. Okay. So here we have had this one I is equal to 0. So this one will be our I is equal to 1 term. This one will be I is equal to 2 iteration. Okay. So let me start our first iteration. So using this main equation. Okay. So I'll begin. Okay. So let's begin our first iteration. So according to the questions, for example, in this question, they only ask y of 2.1 as well as y of 2.2. So we have this one of the iteration, this is the second iteration. So there may be more than that. Okay. So if they ask more also, you have to go up to that. Okay. So first iteration where you have to put I is equal to 0. Okay. So then this star equation, I hope in your notes you have that. Just check whether I am putting correctly. Okay. So if you put I is equal to 0 on that star equation, you will have y1, which is equal to y naught plus h of, okay, so x naught is square. So what is our, in the initial point, y naught is equal to 3 and x naught is equal to 2, no? So we can substitute rather than writing again. Yeah, I can also substitute this one. No? So you can write this one, okay? You just put the I is equal to 0, what will be this equation? Okay, so I'm just gonna write the last one. For the y naught, I can substitute 3. Again, for the h, I can put 0.1. Okay, times. So what is this one? X naught square plus y naught square, no? Okay, what about x naught square? So wherever need, you have to write whatever the details. Okay, then you just substitute. So rather than writing one time and go and even if it is in your paper, let's say this is your details. So if you are in the next page or next page, don't just go again and waste your time. Just copy the things wherever you are doing. So like me, okay? So if you are doing the thing here, you just write it again and just pick it from here, okay? So 2 squared will be 4 plus y naught squared will be 9, okay? Again, h squared by 2, isn't it? So 0.1 whole thing squared divided by 2, okay? Then substitute whatever, I think 2x naught. So 2 times, yeah, 2 times 2 will be 4. Again, 2x naught is squared by naught. So 2 times x naught squared will be 4, y naught will be 3, okay? Plus 2 times y naught to the power cube, isn't it? So 3 to the power cube. Please do yourself and give me the answer, please. Also, our fourth term will be h to the power cube over 6. Okay. Again, 2 plus 4x naught y naught. So 4 times 2 times 3. Okay. Again, 2x naught to the power 4. So a 2 to the power 4. Again, 8x naught square y naught square. So 8 times x naught square will be 4, y naught square will be 9, okay? Plus, what else? 6, y naught to the power 4, so 3 to the power 4. Okay, so can you finally find the answer and then give me the answer in 2 decimal places? See whether you get this answer. Okay, so this is your task now. Can you use your calculator and find me the answer? Find actual this answer, my real answer, and this will be the approximated for the 2 decimal. Okay, 2 decimal place. Let's write down these steps correctly, then substitute. Can you send me the full answer? Okay. So we are getting some answers. 4.848667. Okay. Okay. Maybe correct. 172. Okay. Check your answers. So 4.848666 something like that. Okay. So you can analyze 4.8. So if you truncate this one, 85. Okay. So we are still not finished. Okay. So actually, what is y naught? So y naught will be y of x naught now. So y of 1 will be y of x1. I mean, yeah. So it means y of x naught plus h. That means this is equal to y of 2. This will be y of 2.1. So we have find our answer. Okay. The final answer y of 2.1 is approximately equal to 4.85. So after this step only you have to approximate. Okay. This answer, whatever you get from the calculator also you have to write down. Okay. No need to write everything, but just somehow you have to write this step. From this step to this step, if you are doing calculator, you have to write this step, then only you have to show the approximation. Okay, good. So let's go for, we are not yet in this question, okay? Sometime in the examination, they may ask only this question because of time limit, okay? But here we can practice more than that, okay? So what about y of 2? So hereafter the things are very similar, okay? Simpler one, nothing, just to substitute the things, okay? Okay, so let me go for the next step. Okay, here, let's go for second iterations. So in the second, as I said you, for the y1, okay, y of x1 case, we have used our point of y of x0, isn't it? That is why we are calling as a single step. So what about actually we are trying to find y of 2.1 we have found. Next one y of 2.2, that is the next point now. So in that next point we have to use the details of this one. Okay, rather than this one. We are not going for again forward. This step has been finished and we have to come here. Then we need to go here using these values. Okay. So here you can write our x1 is equal to 1 and y1 is equal to, and what is that? 4.85. Okay, you can use it. Now this is what we're going to use in our this step. Okay. So if you learn how you can feed this one without changing the variable in the calculator, it will be very easy. Okay. So whatever you are doing in the calculator, you have to write something here also. Okay. After writing these steps only, you have to go for the calculator. Otherwise, you will miss so many step marks. Okay. So this is our actual equation. So you can transform this one. So where in this second iteration, I is equal to 1. Okay. So I plus 1 will be y2, which is equal to wherever you are substituting, you can put y1. Okay. So you can write full form. So we know y1 is equal to 8 points. So this is how you have to write. So if you keep the points here in this section, okay, you can just pick it up. Okay. So that's what I'm meaning. Okay. So wherever h come, I can put 0.1, and also x1, wherever x1 comes, you have to put 2 1 square. Wherever y1 come, 8, this one. Okay. Okay, now just substitute all. I think you can find this answer for me. I'll give you the approximation. You can go for 9.72 something. So I keep 9.772. Okay. So that means y of 2.2 is approximately equal to 9.72. So we have found this answer as well as this answer. That's all the task of this. Okay. So can you try this one? Since I don't know, our Zoom has upgraded. Maybe it's going continuously or not. It's not a problem. If it is closed, please try again. Okay. Okay. Can you send me this answer? Only 95 people here. So So there is a calculator trick is there just to, feed the variable. So if you learn that one, if you take some time to learn it, it will be very beneficial for you to save some time. Okay. So that thing is earlier we have fed x1 is equal to 2, y1 is equal to 3. So if you substitute, if you type the equation, it will automatically find. Okay. Similarly, then you can feed the x1 is equal to 2.1, y1 is equal to 4.85. Will automatically. So that trick is your reference. You can find yourself. Okay. That's your, if you are interested, you can try it. Otherwise, it will be, you will lose some marks on, time consuming. Somehow you have to answer all the questions. So even if you are not okay with the calculator also, at least you write something here, okay, and stop your work and go for the next question, and take some half an hour, and then come back to do all these calculations. So at least you will save some, marks rather than, wasting time in one calculation. Just keep here and go for next question. Then at last, after finishing all the question, you come back and do this. So leave some spaces, big spaces, then write this. So even though you didn't do that, you'll just lose some marks. But if you wasted your time here for a long time, let's say if you have 4 questions, you have to know we'll have 2 hours. So each half an hour for one question. So if you use 1 hour for one question, you're going to lose one of the question here. Okay, so that may be the easiest question. So you better go for all the question and do and use your calculator later. Okay, so that you can practice in our continuous assessment as well. Okay, I got one answer. Yeah, that is correct. So I got one answer as 9.7242059. Okay, so here you can approximate here 9.72. Okay, please others also please write down this answer and do yourself. Don't just wait for our mark. Our answers. Okay. Okay, that's that about the Taylor series method. So there are, I have allocated in our quiz 3 questions. One we have done already. So rest of the question you can try. Okay. So similar question, there's nothing different. Okay. So it is for the practice question. So you better do all the questions. Okay. Now let's go for our next method. Okay. Which is known as the Euler's method. Okay. So So all the methods here also, everything we are defining from the Taylor series, okay? It's like a modification of the Taylor series. I mean, we can't modify, but we are just extracting some method from the Taylor series, okay? So this method has been defined as in the Euler's method, okay? So when in the Taylor series method, if you allocate only for k is equal to 1 case, okay, we are taking as the Euler's method, okay? So it means yi plus 1 is equal to yi plus h of f of xi yi, okay? So that until this one, okay, I mean first order, we are taking as another method, we called as the Euler's method, okay? So we can also, derive this one by using our, actually, in our graphical representations. Let's say this is my function, okay? And this is my, let's say, my approximation, okay? So I better use another color. Give me a second. Okay, let's say I have a line, approximated line, okay? Okay. So let's say this is my x node. One second. So let's say this is my initial points, okay? At the initial point, this is my x node, and this is my y node, okay? So actually, this is my y, this is my x, okay? So what if I go for the next step, which is x1? We have the h step size. We call it as a step size, okay? So this is my y1 case, okay? So as we know from our definitions, okay? So what is m is equal to what? So if we also define our m as a dy over dx, isn't it? Am I right? It's equal to x naught, okay? So since we are taking, this is our, I mean, this is my exact function, okay? This is my approximation function, okay? So when I am considering m as, this is a line, therefore m is equal to dy over dx, okay? So also we have given us dy over dx is a function of x comma y. So if I define at x equal to x naught, my function will be x naught comma y naught, okay? So I'm just showing how we can derive this. If you forget this one, or in any case, how you can derive, okay? So that means, so see here, this is my y1, this is my y naught, okay, case. So if we know what is m actually, y1 minus y naught divided by x1 minus x naught, okay, which is equal to our f of x naught comma y naught. Am I right? So I'm just writing for m. M is our, what do you call? In the line, what do you say that? Anyone? What is the y? Sorry, what is the m? for gradient. Okay, gradient of the line. So y is equal to mx plus c is our actually this one. But if you take through the origin, you have y is equal to mx, no? Okay, hope you know those things. I'm just deriving. So if you cross product this one and take off this one, what you'll have? Y1 is equal to y naught. Yes, this part goes this side, and plus this times this. It means x1 minus x naught times f of x naught comma y naught. Okay. So yeah. So I have derived, let's say y1, I have derived y naught plus x minus x naught f of x naught y naught. What about y2? Which is equal to again y1 plus x2 minus x1 f of x1 y1. Okay, similarly I can write up to yn is equal to, so yn plus 1 is equal to yn plus xn plus 1 minus xn f of xn yn. Okay, so as we are taking all the step size are same, okay, this can be written as y. Okay, I'll use another color. It's just a derivation. Okay, so this will be y naught plus h of f of x naught y naught. This will be y1 plus h of f of x1 y1. Similarly for yn plus h of f of x and yn. Since I am taking all the step size are equal. Okay, so this is my final answer. So some book, they, as I said they can use yn plus 1 is equal to yn plus h times f of x and yn. So as like earlier I told you, this is kind of an explicit method. I mean the earlier value only involved. Okay. You can also, that is your reference. Okay. So I'm not gonna do here. Okay. So it is called the modified Euler method. Okay. Please note these things. Okay. You can refer for your other studies, or has maybe this course comes again. Okay. Modified Euler method, which has the implicit method. This is our explicit method. Explicit in the case we are using our the earlier known values. Y naught, yn we know, xn we know, h we know. Then only we are finding our unknown yn plus 1. What if we are finding the implicit case? That is our modified one. Okay, the implicit case, implicit in the sense you will have something yn plus 1 is equal to yn plus h of f of xn comma again yn plus 1 involves inside. Okay, this yn only we are going to find, but yn also coming in the calculation. So that is kind of a your reference. Okay, it's called modified or implicit Euler method. Okay, so it's just a idea of Euler method. Also, the local truncation has been defined in this way. Okay, since we are taking up to the first order for this Euler method, from the second order we can take as a error, truncational error. Okay, there is epsilon between these values. Okay, so that's all about the Euler method. So let's do the question so you'll understand more. So I think I have allocated 3 questions in your quiz. Yeah, but I would like to use another questions here for the exercise. Okay. So maybe again So let's say write this question. It is not in your homework quiz. All the homework quiz you can try yourself. Okay. I'll do one question here, the different question. Okay. The question, let's say, using the Euler's method, find y of 0, 2, and sometimes they may give the question like this, y of 0.4. Okay. From the equation dy over dx is equal to x plus y, where initial condition y naught is equal to 1. Okay, y naught is equal to 1 with step size h is equal to 0.2. So you may know this is 0.2, 0.4. So initially they are taking x as 0. Okay, so I'll change another color. Okay, what they're saying is our initial point x naught is equal to 0, y will be 1. So x naught is, so this is how you have to summarize your question. So this, from this I can conclude x naught is this one, y naught is equal to 1. So I have found this thing. Also h is equal to 0.2. My equation will be dy over dx, which is equal to x plus y. So the next step they are asking 0.2. So I should know if I add h is equal to 0.2. So this is, if this is my x naught, this is actually they are asking for x1. Okay. So if you add another 0.2, you'll have 0.4. Okay. They are asking x2. Okay. So in the question, they may go for like this. Sometimes let's say they ask without y of 0, 2. Okay. Let's say like this. So in this question, let's say, for example, they didn't ask this one, but they asked this one. But actually your x naught is 0. So you have to go 2 steps. Yourself, you have to find the 2 steps. So you can't simply, use this x naught to go for x 0.4, because you have to know this is a single step method. So you have to go from 0 to 0.2. Then only you have to go for 0.4. You can't jump from here to here. You can't use these details to use here. Okay. So that's, you have to be careful, but mostly question they may go in order, but sometimes if they wanted to test your knowledge, so you have to be carefully write the things. Okay. So that's all about the summarization of the question. So let's begin our answers. So since it is a one-step method, it is not a big thing I have. Okay. Okay. Actually, our solution is dy over dx, which is say x plus y. That is actually we know f of x comma y. Our initial point y of naught is equal to 1. And then therefore x naught is equal to 0. Y naught is equal to 1. Okay. So they are asking y of 0.2. Therefore, they are asking y of x1. Also, they ask 0.4. It means y of x2. Okay. So like that. So by Euler method, Euler is a person's name. Therefore, you have to use the capital E. Okay. So these are okay. But if you are using any mathematician names or anything, you have to use the capital letter as a first letter. Now, so Euler method is, as we know, yi plus 1, which is equal to yi plus h of f of xi yi. Okay. So in the sense, if you want, this is our actually x1 term. So I need to put I is equal to 0. So where if I put y1 is equal to y naught plus h of f of x naught y naught. It means y naught will be 1 You can see here, this one. Okay. So just box it so you can see easier. That's y0 will be 1 plus h is equal to yeah, h is equal to 0.2. Okay, 0.2 times. So what is actually our function? This one. So f of x naught, y naught. See, write the details carefully so you won't miss anything, you won't make any mistake. Even though your answer is wrong, you may get some marks for these details. Okay. Yeah. So x naught will be 0 squared, isn't it? 0, sorry, 0 plus y naught will be 1. So my answer will be 1 plus 0.2, so 1.2. So it's not an approximation, so it is coming nicely. Since it is a one step method, so it will be more easy than the Taylor. So I have found my answer for yx1, which is equal to 1.2. Okay. So we have to find this part. So can you try yourself rather than me trying everything? Can you go for y2? What is the y2 and give me the answer? What is y2? Okay. It's good. Good. Someone, the same persons are answering all my questions. I don't know what happened to others. Okay, 1.48. Correct. Okay. So this is how you have to, try the Euler's method. So you can try all our homework quizzes 1, 2, 3, 4. I mean the Euler series. Okay. 3 and 4 question, I guess. Okay. So very simple. Only thing is you have to be carefully analyze the things. That's all. Okay. First of all, you take some time to understand the question and take down all the details carefully like this and things. Okay, then just substitution. So these things you have to be put correctly. Then rest are very simple. Okay. Okay. So let me go for the next method. Okay. So everyone okay? Where's the others answer? Are you all sleeping or what? Okay, do you have lecture at 4? Can you answer me? Anyone have lecture at 4? Okay, anyway. So let's go for our next method, which is also still we are in the single step. Okay. So we are almost finished our course. So another small section there. Then after that we will finish. So hopefully from next week I will finish. Okay, or tomorrow also. If possible, I will take tomorrow also. And then we can finish and you can start to prepare for your continuous assessment. Yeah, assignment in the case, yes, you can try. You can, you know, I told you in the earlier classes, submit like a booklet. Okay, everything as a one way to see. Like take one notebook and write all the questions, so it will be good for you to study also. I can see and give you back. Okay, so also the other thing is within 2 weeks, I think you have the practicals as well as this continuous assessment. So you have 2 or 3 weeks now. Please prepare yourself all the courses. Okay, everyone will have the quizzes as well as I mean the practical session also will be there. So it will be very tight. So you better prepare everything. You can we have almost finished. So you can prepare like a semester exam. You can prepare all the 4 questions, all 4 continuous assessment and things. Okay. Okay, so meantime I will like inform you the time so we can do that thing also. Okay, so let me finish this one. Next method is called as a Range Kutta method. Okay, so this also there are 2 people. Okay, Range as well as Kutta. Okay, so 2 people jointly found this method. So it is also a single step method. This method uses the function evolution at some more points instead of the evolution of derivative of higher order. Okay. So in generally, Runge-Kutta methods of order 2 or order 4 are used to solve the initial value problem. Okay. In this coursework, we are going to, there are Runge-Kutta order 3, they are, more than, I think not more than 4, I guess. But we are going to restrict our things to order 2 and order 4. Okay. So if you are interested, you can analyze about it. But let's see here. Okay. So the first method, so you have to somehow, I think, yeah, I'm not going to use this one. Did I change in your note? Okay. So I have I didn't change anything. I just changed the notation, okay, for the easiness. Okay, let's use that one, okay. Even in the module also, I don't know which one I have sent you. Give me a second. We could, yes, I think in your module I have changed, okay. Not here. So there may be a typo error. So let me write myself so you can change yourself, okay. The module also there may be some typo errors. Okay, so second order, Range-Kutta, second order. It is also kind of derived from the Taylor series, okay? So modified Taylor series things. So it says, let's say our equation dy or dx is equal to f of xy. It is initial value problem, okay? We are going to use this for our initial value problem of first order differential equation. So here I can be, yeah, so there's no I. Okay, so K1, so Range-Kutta has been derived with some steps, okay? So K1 we are taking as h of f of xi yi, I mean, yes, okay? So maybe, for example, K1 may be h of f of x naught y naught, okay? Let's go for K2, which is equal to, let's say, x naught, y naught. Okay, so K2 is equal h of f of, okay, next step is they are modifying then these values, okay. So that's why it is very, very approximate to our, exact equations. So this method is very good than the other method, I mean Euler method, okay? Because it is very closely analyzing the results, okay? There, so x naught, let's say for K2, I can write x naught plus h, okay? Then y naught plus this K1. I think in your note also I put K, please change this K1, okay? So this is Runge-Kutta second order, also called as a midpoint method, okay? I hope you may heard this word somewhere, okay? So it is also kind of a midpoint method, okay? So this is what you have to keep it in mind. So what is K1, what is K2, okay? So, second. So K1 is h of f of x naught, y naught, first one, okay? K2 will be h of f of x naught plus h plus, comma, y naught plus K1, this term. So first of all, you have to find this one, then you have to use that in here, okay? Then actually our next step of y will be yi plus half time. It is called as a midpoint of half of K1 plus K2, okay? Sometimes this may be I, okay? I will be going here, so we are finding the I, no, I will be 0, 1, 2, it's going up to n. Okay, so you can change this one I also. Okay, so no problem. Okay. So Runge-Kutta's second method, which is also called as a midpoint method, what you have to do is, this is fixed, okay? K1 is whatever the h time f. K2 will be h time f, but inside the f, you have to modify the f value xi plus h. For the x value, you have to put xi plus h. For the y value, you have to put yi plus this K1, okay? So this is we called as a Runge-Kutta second method. So if they ask you to solve one of the question using the second, Runge-Kutta second order, second order, you have to use this method, okay? Okay, let me go for the fourth order. So we say Runge-Kutta fourth order, okay? Which has, let's say our equation is dy over dx equal to f of x comma y, which is the initial condition, initial value problem. Okay, now we have to find four values. K1, K2, K3, and K4. Okay, so this is what you have to memorize, or you have to, somehow you have to understand. So K1 is same as second order K1. That means f of xi comma yi. Let's say first of all. Okay, so K2 will be h of f of, see here, this xi plus h by 2. So half of the h. Okay, again yi plus half of this K1. Earlier, so as you know, from rather than the second order, the fourth order will be reaching the exact solution very more accurately. Okay, that's how it goes. So keep it in mind, K1 will be same as the second order one. K2 will be, that K2 is different from here. This K2 will be h of f, whatever the xi, you have to add h by 2. Whatever the yi, you have to add this K1 divided by 2. Okay. So third value will be hf, the same hf. Okay. So xi plus h by 2, that is same. Okay, same like this one. Here, you have to transform this K1 to K2. So first of all, you will find the K2, no? So that K2 divided by 2 only, you have to add here. Okay. So final one, K4 will be h of f xi. So far, xi h by 2, xi h by 2. here only h. Okay. See here how yi's are changing. yi plus k1 by 2, k2 by 2. Next one, we use only the k3. Okay, so this is the important step here. Okay, so other things are just a substitution. Okay, not only this, but also we have to know yi will be yi plus here. Okay, since it's the fourth order now, so it will be 1 by 6. Okay, it's like a 3 factorial. Okay, k1, whatever k1 you have found, plus 2 times k2, okay, plus 2 times k3, plus k4. So if you do so many questions, it will be, somehow you will memorize this, okay. So these steps are very, so you have to memorize somehow. K1, K2, K3, K4, and then you have to find the final answer using this K1, K2, K3, K4. So in this equation. So that is our Runge-Kutta fourth order. So there is a equation also for the third order, but we are not interested. In this course, you don't need to, but if you are interested, you can check it. Okay. Okay. So there are 4 questions under Runge-Kutta method of its mix match. There are 2-4 order 2 and 2-4 order 4 questions there. Okay, it takes so many time, but anyhow, you have to learn it. Okay. So let's do one of the questions. Let me do the okay, let's do one of the question then. Okay, so shall I continue? Okay, now, so let's do the question number 1. Okay, Runge-Kutta question 1. So it says do 2 steps of Runge-Kutta method of second order for the equation dy over dx, which is equal to xy plus y square. That is our function of x comma y. Initial value of f of 1 is equal to 2. H is 0.5. Okay. So we know this is, let's take another color. This is our x naught, this is our y naught. Okay, x naught will be 1, y naught, x naught will be 1, y naught will be 2, h is equal to 0.1. That's all we know, we need, Okay, now, so f of x comma y also, even though if they don't give this one, you have to know this one is this. Okay. Okay, now, let's try. Actually, what is our K1? K1 is equal to HF XI YI. Okay. K2 will be HF XI plus H YI plus K1. So you may remember in our second order, fourth order, first one and the last one is the second order's first one, second one. Here we have to use K1. There you have to use K4 here. Okay, so you may have Notice the similarities. Okay. Okay. So now let's find our answers. Okay. So K1, which is equal to HF Xi Yi. So in case of I is equal to 0, okay, so K1 will be HF X0 Y0. Okay. So actually what is our H will be 0.1. Am I right? And then what is our function? Function f of x equal to xy plus y square. Okay. So according to that you have to, so what is fxi yi? So it will be xi yi plus yi whole thing square. Okay. In case of 0, it will be x0 y0. So x0 is what? X0 is our 1. Y0 is 2 plus again yeah, this one y0 square. This will be 2 square. Am I right? So this will be like 0.1 times 2 plus 4, 6. So it will be 0.6. So this is my K1. I have find my K1. Okay. So what about my K2? K2 will be h of f of yeah, xi plus h, yi plus K1. So if you transform this one, so like let's say for I is equal to 0, I have x naught plus h, y naught plus K1. Okay. So it is like h of h will be 0.1 times functional value. So see here, this one is h of f of. So what is this x? X naught will be 1, isn't it? Yeah, 1. 1 plus h will be 0.1. This will be 1.1. Okay. This will be 2 plus k.1 will be 0.6. So if you put that one, it will be 2.6. So the functional value of 1.1 comma 2.6. Is that correct? So rather than I am substituting this x naught plus h, y naught plus k, I know already the value. So it's better to substitute that one. X naught will be 1 and then h will be 0.1. So I need to find f of 1 comma 1 and y naught will be 2 and my k1 already I have found 0.6. So I have included, so 2.6. So if you substitute here, so I'll get 1.1 times 2.6 plus 2.6 whole thing square, isn't it? So what is this answer? So this is our first iteration. Okay. So they are asking do 2 steps. So it means do it 2 iterations. So this is our first iteration. So what is K2? Okay. So K2 something like 0.962, isn't it? Good. Okay, that's all. K1, K2. If you find the K1, K2, that's all the things. So what is our Y1? Y1 will be actually the Rangekutta second order yi plus 1 is equal to yi plus half of K1 plus K2. No. So this will be, if you substitute y naught plus half of K1 plus K2. This means y naught I know 2 plus half of K1 will be 0.6, K2 will be 0.962. So if you get the answer, it will be, what is the answer? It is equal to okay, so it will be 2.7, the 0, uh, 1, this will be 1.562, no, Please do with the calculator, okay? So when you divided 0.7, no. Should be 2.7. Check your answers. 14. Yes. So actually, what is this one? Y1 is equal to y of 1.1, no? Y of 1.1 will be our 2.781. So they ask you to do another second iteration also. So if they say do 2 steps of Rangekuta, do 2 iterations. Okay. So we have find for I is equal to 0. So what about for I is equal to 1 case? Okay. So hope everyone following. If you have any doubts or anything, you can ask also. You don't be silent. Do something, write something and do some calculation now itself. Okay. Okay, let's go for the second iteration. So there's nothing in the second iteration. Just you're gonna use the things and this is substitution. So my K1 again. Okay, this is my second iteration. So in that I'm gonna use my K1, which is equal to f of xi. So x1, y1. Okay, here I can change my xi, yi. Okay. So now I know my x1 will be 1.1. Again, y1 will be, I have already found 2.781. So that's what I'm going to use. H is also 0.1. Okay. Very simple. See, h1. So h is equal to 0.1. Whatever the functional value, you just substitute f of 1.1 comma 2.781. That's all. So actually our function f of x comma is, what is the function? Xy plus y1 square. Okay, according to their question, it's just changing. This is only changing. Okay, this will be 1.1 times 2.781 plus 2.781 whole time square. We are not gonna do anything manually. Just we're gonna feed in the calculator and find the answer. So it's not a big thing, no. So what will be this answer? Also, can you find K2 and also Y2? Please, everyone work on it. Okay, good. Okay, so I got one of the answer 1.079 something. No? So I can change into 2 decimal places. After you write the answer, you just write in the approximate answer. Okay. Maybe between 1.08. Okay. Okay, good. So how about K2? So K2, where you have to use this K1. So if you made a mistake in K1, it will be ruin your all the answers. So you better carefully find the K1 because even in the fourth order also, K1 only used in the K2, K2 only used K3. So you have to be carefully find the answers, okay? What about K2? K2 in the sense you have H f of x1, x1 plus h, y1 plus k1. So it will be like 0.1 times function of, so this will be 1.1, okay. This will be 2.781 plus 1.08. So it will be 3.861. So the thing is, okay, consider here, when you are substituting the K1, don't put this answer. keep this answer, but put this answer. Okay, whatever the answer you have got, like for example, 2603061, whatever the, you get the earlier answer. Don't put the approximate answer because it will give you some, error, much error. Then to reduce the error concept, you just put the, you done here like this, but you use the earlier a full answer for this purposes. Okay, so it may be somewhere around, 1.95 and 540. Yes, okay. Is that 4.953433 something? Yeah, 3453. Yeah, 5343305. So somewhere, you know, 1.95. Okay. Okay, now what about the y2? So the y2 will be y1 plus half of k1 plus k2. Is like y1 we have 2.781. See, simply we are reaching small in the small steps. So that's what the numerical is. Okay. So 1 point here you can use a full form, both full forms. Okay. So maybe around approximately 4.297. Yeah, somewhere like that. Okay. So when the calculation, so for the answer you can show this one, but in the calculation you use the, full answer. So you can reduce some errors. Okay, this is all about the second order Runge-Kutta method. So let's do one of the fourth order so we can finish at 4 o'clock. Okay. So let me choose the question. Yeah, second question. Shall we do that? Start to write the question. So if you are at a mathematical people, you are very interested in the calculation. So you better do all the questions thing. Okay. Practice yourself earlier. Don't wait until the examination to study. Okay, so second one, it's for the fourth order Runge-Kutta and computer approximation of y of 2.1 as well as y of 2.2. So each has two steps. You have to go 2 iterations. As a solution of differential equation, differential equation is, so only thing is different here in the examination or anything. Only they have changed this function and these values. That's all. All the methods are same. So only thing is we have to just substitute the value that they have given. Okay. Okay. So the question is using the fourth order Runge-Kutta method, solve it. Okay. So now H they didn't give, no? Okay, H also should be 0.1. Okay. So you can see from here, if they don't give also, no, it's a single step, but 2.1, 2.2. So you can predict, okay? So in the examination, they will give you anyway. So H is equal to 0.1. And then, yeah. Okay, so here from this, you can analyze what is X naught, and here X naught will be 2 and Y naught will be 3. Okay, and this one is our function. That's all, isn't it? Okay, now let's compute the K1, which is the similar one of X1, Y1. Xi, Yi. Similarly, K2 is equal to H of F xi has been increased by h by 2, yi has increased by k1 by 2. Similarly, k3 will be hf of xi plus h by 2 same, but here they will transform k2 by 2. So after finding the k2 only, you can find the k3. And k4 will be h of xi plus h, yi plus k3. Okay, that's all. So and then yi plus 1 will be yi of 1 divided by 6 of k1 plus 2 k2 plus 2 k3 plus k4. Okay, that's all. So shall we do the first step? So you know x naught will be 2. So we are one step away. Okay, for the 2.1. Okay, let me go for this window. Okay, shall we begin? First iteration where we can put I is equal to 0. So can you quickly find the answer of K1, K2, K3, K4 for this one? This will be h of x. So since we are I is equal to 0, so I is 0, this 0. This will be h of, actually our function is x naught to square plus y naught to square. So it is like a 0.1 times. If you are writing the decimal like this, please put the brackets, okay? X naught squared will be 2 squared, no? 4 plus 3 squared, 9. So this is kind of a simple one, no? So what is the answer for this one? This will be 13. 13 times, this will be 1.3, that's all. Okay, use this K1 to K2 and do the, can you find the K2? Yes, good. Go for the K2. So where you have to be carefully put x naught plus h by 2. Okay, so 0.1 divided by 2. So just substitute in the calculator carefully. Okay, yes, that's correct. So it will be h of f of x naught h by 2, y naught k1 by 2. So what you have to substitute is 0.1 in the function. So first of all, you write the function as it is, okay? So actually, x naught is equal to 2, no? I'll change the color. So let's say x naught is 2. H by 2 will be 0.1 divided by 2. So it is like 0.005. Is that? Comma. Y naught will be 3. K1, we have find 1.3 divided by 2. So please put in the calculator carefully. So I don't know what is this one. 3.065. Is that something? Just carefully put the things. Is that no 0.65? Is that correct? 2.05 and 3.65. So please feed in the calculator correctly. I mean mistake. So if you put like this 0.1 times, so 2.05 whole gen squared plus 3.65 whole gen squared. That's all. Yes, we have to correctly write here and then substitute in the calculator correctly. That's all. Okay. I got so many answers. Okay, thank you. The answer is 1.7525. Good. Okay, what about the K3 as well as K4? So K3 will be hf of xi plus h by 2, the same. So it will be 0.1 times f of 2.05 same. This only gonna change. So 3 plus 1.7525 divided by 2. So that thing. So it will be so what's the answer? Can you check your answer? 77. I think the answer will be K3 will be I think 1.9227 or something. This will be 3.87625. Please, so correct? So 0.8, no? Okay, that's fine. 9227, good. K4. K4 is 2.8643, good. It's like, yeah. Altogether, you can find the Y1 as well. So you have to put in the Y naught value plus 1/6 K1 plus 2K2 plus 2K3 plus K4. Okay, yeah. So how about Y1? Y1 in the sense the value of 2.1. Yes. 2.1 will be the value of 3 plus 1/6 of K1 is equal to 1.3 plus 2 times. Okay, I write again. So Y2 is equal to Y1 plus 1/6 K1 plus 2K2 plus 2K3 plus K4. So if you substitute this one, this will be 3 plus 1/6. You have said this is 1.3 and second one 2 times 1.7525. You can put the actual value or 1.9227 plus 2.864. So if you calculate this one, something, what is this one? 4 point something, because 3 plus something, no? Okay. 4 point, yeah, 919. Okay, good. 667. So approximately 4.92. Isn't it? So this is the value of Y of 2 point. So 2.1. Yes. Okay. So what is that saying is from here, it is a function. So x square, y square, no. So it is an increasing function maybe. So at the point x naught, they have given this is 3. So maybe at the x1, it will be somewhere like this. Okay, 4.92. Okay. So that's what it says. So it is like an increasing. Okay. So next step is x1, x2. Yeah, you can continue the second iteration also. So when you practice more question only, you may be good at the calculator as well as This thing also, when you write again, you can get used to it. Okay, so we have 3 to 4 minutes. So can you answer me the second iteration? So there, what is K1, K2, K3, K4, and as well as and Y2, which is Y of 2.2. Well, I'll write my answer and check whether, okay, this may be 2.86, the approximated value, okay? Maybe this one 4.49 and then 5.594 something. This one 11.536 something. Altogether, it is coming, I don't know, check the answer. It's 10.68 or something. Okay. So this is how you have to give the nice answers. Also, please try to get the past papers and see whether you can, this point of time, you can answer all the questions. Okay, we have a small, we have done the single step method. So next is, I'll try to do the multi-step method. So that's all our course. Okay, we have come to the end of the point. Okay, so yeah, that's all about today. So please note down this answer and check whether maybe that's wrong, but this is one of the answer I have. Also practice all the questions now itself in the homework quiz number 7. Taylor series there are 3 questions, Euler 3 question, as well as Rangekuta also there are 2 more questions there. So take your time to practice all the questions, and you can check with your friends also, because you also don't have the full answers. So you can, if you can check your answer within yourself, and if you have any major differences, you can check and recorrect. Okay, so I'll stop here. Okay.